Welcome to my channel. I'm Zhangjing Xu. Let's look at the problem 39 in chapter 22. Chapter 22 is about Gaussian's law. So now we look at this system. We have the spherical non-conducting object. So keyword non-conducting tell us the charge is uniformly distributed inside the object, right? And the charge density is rho e. And then for the inner object, the radius is r0, and then the outside is a shell. It's a mantle, spherical shell. So keyword mantle tell us this is a conducting object, right? And then for conducting object, the charges is located at the surface. The inner radius is r1, outer radius is r2. Net charge is positive q. Now we need to determine the electric field density in different regions. So as we learned in this chapter, we apply the Gaussian's law. The Gaussian's law tells us the electric field density times the Gaussian surface equal to enclosed charge divided by epsilon naught, right? So E equal to the enclosed charge divided by 4 pi epsilon naught r squared. So for A is the region where the r is larger than naught, smaller than r0. So we can see this is R. And then we can draw a Gaussian surface, look like this one. Agree? Yes. Now we look at the charge enclosed. So the charge enclosed is the density, charge density times the volumes. Agree? Because this is a non-conducting object. Input this Q enclosed inside, we can see 4 pi cancelled, pi is cancelled, and R2 cancelled. So we get a final answer, look like this one. Agree? The second case is the R is larger than R0, smaller than R1, so it is there in this space. So in this space, we can draw a Gaussian surface, look like this one. Now we look at the enclosed charge. So enclosed charge just this non-conducting spherical object, right? So this is the density times the volumes. For this object, the volumes is R0. So now we input the enclosed charge inside. You can see 4 pi cancelled. So you get the equation look like this one. The third part is the R is larger than R1, smaller than R2. So R is larger than R1, smaller than R2, we can draw it look like this one. But there we need to pay attention. This tells us this is a concentric mantle spherical shell. So the mantle tells us this is conducting. For electric field density inside the conducting object, the electric field density is always 0, right? So E equal to 0. We don't need to do any calculation. The D part tells us the R is larger than R2 there. So we can draw the Gaussian surface, look like this one. Now, what charge enclosed? First one, the charge by this non-conducting spherical object. So use the charge density times the volumes. And also the charge on this mantle, right? Conducting shells, capital Q. So we input it inside, get answer at there. Thank you.